What if I told you that a breakfast eaten by Japanese fishermen for over 1,000 years could reverse your body's insulin resistance in just 14 days? The most shocking part? You're probably eating breakfast in the exact wrong order, and that simple mistake is quietly destroying your metabolism every single morning. Here's what makes this different from every other diabetes diet you've tried. While Western medicine tells you to cut carbs, count calories, and fight your cravings, this ancient system works with your body's natural defenses. By the end of this video, you'll understand 3 invisible mechanisms happening inside your digestive tract right now, and how a specific sequence of foods can turn your gut into a glucose-trapping machine. And first, we need to talk about why everything you've been told about breakfast is backwards. Type 2 diabetes isn't just about blood sugar numbers on a meter. It's about your cells becoming deaf to insulin signal. Picture this. Your pancreas is screaming at your cells to absorb glucose, but they've stopped listening. This is insulin resistance, and it's happening silently in millions of people who don't even know they're pre-diabetic. Most people think they're doing the right thing. Whole grain toast, orange juice, a banana. These seem healthy, but here's the critical mistake. When you eat fast-digesting carbohydrates first thing in the morning on an empty stomach, you're essentially throwing gasoline on a fire. Your blood sugar rockets up, your pancreas panic releases insulin, and your cells get flooded with more glucose than they can handle. Do this every morning for years, and you've trained your body to become insulin resistant. Now consider this paradox. Japan has one of the lowest rates of type 2 diabetes in the developed world, yet they eat white rice, a high glycemic carbohydrate, almost every day. How is this possible? The answer isn't what they eat, it's the invisible architecture around how they eat it. The traditional Japanese breakfast isn't a meal, it's a metabolic defense system disguised as food. Let's acknowledge the elephant in the room. Natto looks weird, smells strange, and has the texture of something you'd find in a science experiment. It's sticky, slimy, and when you stir it, it forms these bizarre stringy webs. But inside those sticky strings is something extraordinary, a triple-threat weapon system that's been protecting Japanese metabolic health for over a millennium. First mechanism, the glucose trap. When you eat natto before rice, you're coating your digestive tract with a viscous, gel-like substance called gamma-polyglutamic acid, or GPGA. This is what creates natto's signature sliminess. Here's the critical part. When rice arrives in your stomach and intestines, it doesn't hit your gut lining directly. Instead, it has to wade through this thick, sticky barrier. Picture trying to run through waist-deep mud versus sprinting on pavement. The starches from the rice get trapped in this viscous web, and their breakdown into glucose happens much more slowly. This means instead of a glucose spike that looks like a cliff, you get a gentle hill. Your pancreas can keep up, your cells don't get overwhelmed, insulin resistance doesn't develop. Second mechanism, the insulin sensitizer. Regular soy contains compounds called isoflavones, but they're locked up in a form your body struggles to absorb. When the bacteria, Bacillus subtilis, ferments soybeans into natto, something remarkable happens. These bacteria pre-digest the isoflavones, converting them into aglycone forms, specifically genistein and didzine. Think of it like someone pre-chewing your food for you, except in this case, the bacteria are unlocking compounds that make your cells actually listen to insulin again. Research shows these aglycone isoflavones directly improve insulin sensitivity. Your cells respond better to insulin's signal to absorb glucose. You're not just managing the glucose spike, you're fixing the underlying communication breakdown between insulin and your cells. Third mechanism, the inflammation assassin. While most people know natto kinase for its ability to dissolve blood clots, there's a deeper diabetes connection that gets overlooked. Chronic inflammation and oxidative stress are like invisible termites eating away at your insulin sensitivity. They damage cell membranes, interfere with insulin signaling pathways, and create a state of metabolic chaos. Natto kinase acts as a systemic anti-inflammatory agent, reducing these silent saboteurs. When you lower inflammation, you remove one of the major roadblocks preventing your cells from responding to insulin. This is the third layer of protection. You're slowing glucose absorption, improving insulin sensitivity, and simultaneously removing the inflammatory barriers that cause resistance in the first place. The Japanese breakfast isn't random. It's a precisely sequenced system designed to protect the pancreas. This is called Ichiju Sansai, which literally means one soup, three sides. But this isn't just about variety. It's about a specific order of operations that creates a metabolic cascade. Each component primes your digestive system for the next, creating a layered defense that protects you from glucose spikes. Component 1, miso soup. This isn't just comfort food, it's a strategic first move. The warm liquid containing probiotics from fermented miso stimulates something called the incretin effect. These are gut hormones that basically send an advance warning to your pancreas: glucose is coming, get ready. Your pancreas starts preparing insulin in response to food in your gut, even before glucose hits your bloodstream. This means when the rice does arrive, your body isn't caught off guard. The practical application: drink about half a cup of miso soup before eating anything else. You're activating your gut-pancreas communication system. Component 2, natto or fish. After the soup primes your system, you eat the protein and fat anchor. High-quality protein and healthy fats do two critical things. They trigger satiety hormones that tell your brain you're full, and they prevent what's called the second meal effect. Here's what that means. If you eat a carb-heavy breakfast with no protein or no fat, your blood sugar will spike, then crash. When lunch comes around, your body is in a vulnerable state. It overreacts to the next meal, spiking even higher. The protein and fat anchor prevents this vicious cycle. With natto specifically, the instruction is to mix it vigorously. Those sticky strings you create aren't just for show. They're maximizing the GPGA content that will trap glucose later. Component 3, vinegared sides. Next come the pickles or vinegar-dressed vegetables, the tikumono. This is another invisible shield. Acetic acid from vinegar slows gastric emptying, which is just a fancy way of saying it makes food leave your stomach more slowly. Why does this matter? Because if food dumps quickly from your stomach into your intestines, glucose floods your system all at once. The vinegar creates a traffic jam, forcing a slow, controlled release. The practical application is simple: a small side of pickled cucumber, radish, or any vegetable with a vinegar-based dressing. Component 4, small rice bowl. Finally, and this is crucial, you eat the rice last. By the time rice enters your digestive tract, it's walking into a crowded room. There's viscous GPGA coating your gut, there's protein and fat slowing everything down, there's acid creating a traffic backup. The glucose from rice enters this crowded environment and gets absorbed as a gentle curve instead of a violent spike. The key is portion control. A small rice bowl, about half a cup, which equals approximately 25 to 30 grams of carbohydrates. This isn't depriving, it's strategic fuel delivery. A study in the British Journal of Nutrition put numbers to this effect. When researchers fed participants a breakfast of natto combined with viscous vegetables like okra, they measured something remarkable: a 27 to 28% reduction in acute glucose and insulin response compared to a control meal with identical macronutrients but no viscosity. Think about that. Same calories, same protein, same carbs, but just by adding viscosity, they cut the glucose spike by more than a quarter. This proves that texture isn't just about taste, it's a metabolic variable. Intervention trials show that consuming this specific breakfast structure for just 2 weeks significantly improves the composite insulin sensitivity index in overweight individuals with impaired glucose tolerance. 2 weeks, that's not a lifetime commitment to a restrictive diet. That's a 14-day experiment that could fundamentally change how your body processes glucose. Regular natto consumption increases populations of specific bacterial genera, Blautia and Bifidobacterium. These aren't random bacteria, they're directly associated with lower rates of metabolic syndrome and lifestyle-related diseases. You're not just changing your breakfast, you're remodeling the bacterial ecosystem in your gut to favor metabolic health. You don't need to become Japanese to benefit from this system. The principle is simple: create viscosity, eat in sequence, control portions. For people who can't stomach natto, and let's be honest, that's most Westerners at first, use alternatives that create that same viscous barrier.
Okra is the closest match. It has that same slimy quality when cooked. Other options, chia seeds in water, which creates a gel, flaxseed dressing on a salad, even a spoonful of psyllium husk in water. The goal is to coat your digestive tract with something thick and sticky before carbs arrive.
For the time-constrained, try high-quality instant miso paste with added seaweed. Mix it with hot water, and in under 60 seconds, you have your probiotic primer. The seaweed adds extra fiber, enhancing the viscosity and gut priming effect. Here's the lowest effort, highest impact intervention. You don't even need to change what you eat, just change the order. Whatever your current breakfast is, rearrange it. Fiber and fermented foods first, then protein, then carbohydrates last. If you normally eat eggs, toast, and fruit, flip it. Eat the fruit with some nuts for fat and fiber, then the eggs for protein, then the toast last. This simple resequencing can dramatically flatten your glucose curve without requiring new ingredients or recipes. One breakfast doesn't cure diabetes, but one breakfast repeated becomes a pattern, and a pattern becomes a metabolic identity. When you consistently avoid glucose spikes, you give your pancreas rest. When your pancreas isn't constantly firefighting, it can heal. When your cells aren't constantly flooded with insulin, they start listening to it again. This is how insulin sensitivity gets restored, not through a single heroic intervention, but through consistent, intelligent food sequencing. Lower inflammation means reduced cardiovascular risk. Better insulin sensitivity means easier weight management. A healthier microbiome means improved immune function, better mood, clearer skin. The breakfast system isn't just about diabetes, it's about systemic metabolic optimization. For 1,000 years, Japanese culture has intuitively understood something that Western medicine is only now measuring with glucose monitors and insulin assays. The order, texture, and composition of a meal matter as much as the ingredients. We've been so focused on what to eat, low carb, low fat, high protein, that we've ignored how to eat. Sequence matters, viscosity matters, microbial fermentation matters. Try this breakfast system for 14 days and track what happens. Use a continuous glucose monitor if possible, or just notice subjective changes, energy levels, cravings, hunger patterns. The research suggests you'll see measurable changes in insulin sensitivity in this time frame. This isn't about cultural appropriation or rigid rule following. It's about understanding mechanisms and adapting them to your context. You don't need to eat natto if you hate it. You don't need to buy special Japanese ingredients. You need to understand viscosity, sequence, and portion control, then apply those principles to whatever foods are available and enjoyable for you. What if a 1,000-year-old breakfast really could fight type 2 diabetes? We now know it's not what if, it's how. The mechanisms are clear, the research is compelling, and the implementation is accessible. The real question is, will you try it? Because somewhere right now, a Japanese grandmother is eating her morning bowl of natto and rice, completely unaware that she's executing a sophisticated metabolic defense strategy that modern science is only beginning to understand. Maybe it's time we paid attention.